Hello, good morning, students. Let us try to understand the law of mass action, student, that I have taken from the comprehensive chemistry, student. Okay, let us have a look over it, student. What is meaning of the application of law of mass action to the chemical equilibrium, right, student? So, law of mass action, what they are saying, student, when you're talking about the law of mass action, okay, law of mass action. First of all, you try to understand law of mass action. So that is, they are saying rate is proportional to what is, that is active mass of the reactant, active mass of the reactant raised to power their coefficient. Okay, that is was the law of mass action, right, student? If you are writing, that is, you can remove, that is proportionality constant, put the k and a power a and b power b. Okay, so that is what they are talking about, that is law of mass action. Okay, up now in another term, this active mass is also there. One more topic is there, student, that is what active mass. Active mass, active mass means that is moles per liter, you know, moles per liter, that is what active mass, and it is represented by square bracket, right, student? So that is n by v, or you can say mole, we can write w by m into w by m into b. That is what is active mass. So dear student, let us have a look over it in this question. What they are saying, that we are applying the active mass on this question. So how we can apply? They are saying, by applying law of mass action to a reversible reaction in equilibrium, it is possible to derive a simple mathematical expression known as law of chemical equilibrium. Let us consider a simple reversible reaction A plus B giving rise C plus D in the reversible process, in which the equilibrium exists between the reactant A and B and the product C and D according to law of mass action. So rate of forward reaction is proportional to what? Concentration of A and B, active mass of A and active mass of B. So if you are removing the proportionality constant, so that is Kf, active mass of A and B, where Kf is the rate constant for the forward reaction. A and B are the molar concentration of reactants A and B respectively. Similarly, rate of the backward reaction, so C and D, so Kb, active mass of C and D, where Kb is the rate constant for the backward reaction, C and D molar concentration of the products and C and D respectively. At equilibrium, the rate of two opposing reaction becomes equal. Therefore, at equilibrium, rate of forward reaction equal to rate of backward reaction. Rate of forward reaction equal to rate of backward reaction. So Kf is equal to Kf, active mass of A, active mass of B equal to Kb, active mass of C, D. So Kf by Kb is equal to product of CD upon AB. Since Kf, Kb are the constant, therefore the ratio Kf and Kb also constant and represent Kc, that is equilibrium constant. So Kc is equal to Kf by Kb and active mass of C and D upon active mass of AB. So this is what the equation. Now let us have a look over the Kc. The constant Kc is called equilibrium constant. The subscript C indicate that Kc expressed in term of the concentration mole per liter of the reactant and product. The concentration in the is in the expression 7.3 are the equilibrium concentration. For a general reaction, A mole of A, B mole of B, giving rise C mole of C and D mole of D in the reversible process, the expression for the equilibrium constant can be written as Kc is equal to active mass of C power C, active mass of D power D upon active mass of A power A and active mass of B power B. This is our answer. So now student, how can you define the equilibrium constant? The equilibrium constant Kc may be defined as the ratio of product of the equilibrium concentration of the products to that of the reactants, with each concentration term raised to the power equal to the stoichiometric coefficient of the substance in the balanced chemical equation. Okay, so equation 7.3 and 7.4 are the expression for the law of chemical equilibrium. Law of chemical equilibrium may be stated as क्या, at a given temperature, the ratio of product of equilibrium concentration of the product to that the reactant with each concentration term raised to the power of equal to the respective stoichiometric coefficient in the balanced chemical reaction. So that is, the concentration ratio is C power 80 mass of C power C D power D upon A power A B power B is called the concentration quotient, is called the concentration constant, and is denoted by Qc according to law of chemical equilibrium. At equilibrium, Qc is equal to Kc. So this is what the equilibrium constant. Thank you so much for watching, friends.